Hi students. So today we will see the transportation model, and in that we will see the first method, northwest corner rule. So first we will see what is a transportation model. So if there are some factories in different cities and we have to supply to the other cities the product of that factory. So here you can see this mathematical formulation of a transportation model. So here we can say distribution center and demand. Now here plant 1, 2, 3. So we will consider here there is a plant suppose in a Mumbai, then another plant maybe in a Delhi, and another plant maybe in a Chennai. So these are the plants, and here in the Mumbai this is a supply. So or we can produce, suppose for example we can produce 100 units in a Mumbai plant, in a Delhi suppose 150 units, and in a Chennai suppose 200 units. We are producing this in the Mumbai, Delhi and Chennai units, and at the same time there is a demand from the some cities. So we will consider some small cities. Suppose here we can consider here Pune is the city, Ahmedabad another 3 number and 4 number, these are the cities, and we will consider this Pune demand is suppose a 150 unit, Ahmedabad demand is suppose 60 unit. Likewise, so this is a mathematical formulation of transportation model. Means what? In some cities there is a manufacturing unit and we have to supply that product from that manufacturing unit to throughout the country, we can say. And this x11 or x12, this is nothing but the cost. So from Mumbai to Pune, this x11 is a cost, we will see in the problem. So this is a mathematical formulation actually. Now how to solve this problem? So here procedure to solve the transportation model. So first step is make transportation model. So we have to prepare a mathematical formulation, then find a basic feasible solution by any method. So there are number of method for basic feasible solution, we will see that one by one. Then perform optimality test over there, again iterate toward an optimal solution and check for the optimality. So these three steps we can see afterwards in upcoming lecture. So today we will see how to make a transportation model and find basic feasible solution. So for finding out the initial basic feasible solution, so these are the methods. Here you can see these are the methods to find out the initial basic feasible solution, or that is called as initial basic feasible solution, IBFS in short form. So first method is a northwest corner method, or it is also called as northwest corner rule. NWCR is also called, or northwest corner method. Then second is a row minima method. Third one is a column minima method. Then least cost method, and last one is a Ogle approximation method, or it is called as a WAM, Ogle approximation method, or it is also called as a penalty method. So our aim is to transport the product from one city to the another city with a minimum cost. So we will start with the first method, that is NWCR, northwest corner rule or northwest corner method, and how to solve the problem by northwest corner rule we will see. So this is a problem. So you can see in the problem. So here we can consider these are the factories. Suppose these are the factory Ahmedabad, Ernakulam and Kanpur. In these three cities there is a factory, and Ahmedabad product size, or we can supply from Ahmedabad, is 30 units, from Ernakulam 40, and from Kanpur 50. That is a supply we can having. Then the demand here Mumbai, Kolkata, Delhi and Chennai. So in the Mumbai demand is 35, Kolkata demand is 28, Delhi demand is 32, Chennai demand is 25. Now what is this cost? 6, 5, 8. So these are the transportation cost. Means if we supply one product from Ahmedabad to Mumbai, then it will cost 6 rupees for one product. If we transport from Ahmedabad to Kolkata, it will cost 5 rupees. Similarly, suppose Ernakulam to Chennai, so it will cost 7 rupees. So these are the cost, or we can say this is a cost matrix, and here supply and demand. So once we have understood the problem, then the first step is to check the problem is balanced or not. So first step, important step, is problem is balanced or not. What is mean by balance? So here we have to check supply is equal to demand or not. So in this case, if we check the supply, we will add this supply is 30 plus 40 plus 50. So that will be the 120, and demand, that is a 35 plus 28 plus 32 plus 25. So that is also equal to 122. So supply is equal to demand, so this is a case of a balance problem. So here we can write 120 is a supply and 120 is a demand. Now we can solve this problem by the northwest corner or any initial basic feasible solution method. So first step is important step, problem is balanced or not. If it is not balanced, then we have to add the dummy row or dummy column that we will see in the upcoming lectures, unbalanced type of problem. Now here we are solving the first step, that is a northwest corner rule. So here northwest corner rule. So here we have to put the side. So initially, so this side is a north side, then here it is side south, this is east, and this is a west. So we have to first give the allocation at northwest corner. So in this matrix, so here this is a matrix where we want to solve, this is a cost matrix. So in this matrix, first in the northwest corner we have to give the allocation, means northwest corner. So this is north, this is west. So first this 6 is at a northwest corner, so we will give the first allocation at this 6. So how to give the allocation means what? So in the Ahmedabad 30 supply is having, and in the Mumbai demand is a 35. So we will first allocate at this location. So 30 is a supply and 35 is a demand. So maximum we can supply is 30, but demand is a 35, but we are having only 30 units in hand, so we can supply maximum 30 units to the Mumbai. So from this supply is finished, so a remaining supply is 0, and from this 35, 30 units are fulfilled, so 5 demand is remaining from the Mumbai city. Okay, now here we have given at the northwest corner, here we have given the allocation. Now here supply is finished, so we will cross this. So I will cross this because there is no supply left, so we will not give in the next step. Here there is allocation. Okay, now coming to the next, second row and third row. So in the second row again check for the northwest. So northwest is a 5 is the element northwest. So here 40 is the supply, but demand of Mumbai left is only 5. So 40 is supply, 40 units we are having, but demand is of a 5 units only. So we will give the 5 units here. Now this demand is fulfilled, so remaining demand is 0, and from this 40 we have given only 5, so remaining 35 supply here. Now here this column becomes 0, means Mumbai demand is fulfilled, so we will now cross this column because here demand is fulfilled, here it becomes 0. Now from the remaining elements, so remaining elements are 11, 9, 7 and 9, 7, 13. So from these element, 11 is a northwest, 11 is a northwest corner. So this matrix only remaining, I will use another color. So this is only left, this matrix is only left. So from this, now 11 is at a northwest corner. So here supply is 35 and demand is a 28. So we will give the demand 28 here. We are having 35 units in hand, but demand of Kolkata is only 28. So we will fulfill all the demand. So demand is fulfilled, remaining demand is 0. So from this 35 we used 28. So 7 is left here. Now here this column becomes 0. So we will again now cross this column. Okay. Now from 9, 7, 7, 13. So which one is at northwest corner? So 9 is at northwest corner. So here supply is a 7 and demand is 32. So we will give the 7 here fulfill demand. So remaining 25 demand is unfulfilled and supply is finished from 7 to 0. Now we will cross this row because this row becomes 0. Now from 7 and 13. So 7 is at northwest corner. So here 50 is a supply and 25 is a demand. So we will give the 25 here. So this demand is fulfilled. Okay, and only 13 value is left. So here 25 is a supply and here remaining 25 is a demand. So we will give the 25 here. So now likewise this supply is fulfilled, this demand is also fulfilled. So this is how we can solve the northwest corner. So I will put this allocation in the next matrix. I will copy these allocations here. I have prepared this matrix already. So I will put the matrix here and we will put the allocation, what allocation we have given. So I will put here. So here in the at this 6 location the allocation is, at this 6 the allocation is 30. So at this 5 allocation is 5, this 11 allocations are 20, this 9 allocations are 7, this 7 allocations are 25 and this 13 allocations are 25. So these allocations we have given in the matrix by the northwest corner method. Now we have to calculate the initial basic feasible solution. So initial basic feasible solution means what? We have supplied 30 units with the cost of 6 rupees. So we can multiply that 30 into 6. So that is a cost, plus we have supplied 5 unit with the cost of 5. So plus 5 into 5, plus we have supplied 11 unit 28 units with the 11 rupees cost. So that 11 into 28. Similarly, plus 9 into 7, plus 25 into 7, plus 25 into 13. And if you make the addition of all these, so we will get the answer is suppose 1076. So this is a initial basic feasible solution of the problem by northwest corner rule. So this is initial basic feasible solution. Now if you see in the mathematical statement, so here make a transportation model. So here in the first step we have made the transportation model and we have given the allocations, and second step is find a basic feasible solution. So that is initial basic feasible solution. So we have calculated that for this case 1076 is the initial basic feasible solution. Now perform a optimality test, iterate toward optimal solution and check for optimality. We will see in the upcoming lecture after completion of all these methods. So in today's lecture we have covered this northwest corner method, row. Now in the next lecture we will cover row minima, column minima and least cost. Then we will cover the Vogel approximation, and then we will go for a optimality test. So that is MODI method, or we can say modified distribution method is used for optimality test, modified distribution. Okay, so today we will stop here, and in the next lecture we will see row minima, column minima and least cost method. Thank you.